Hello students, today we will discuss the flow of current in active mode. Flow of current in active mode. Consider a transistor of PNP. Consider a transistor of PNP transistor, which is activated in the mode of operation is in active mode. Active mode. Active mode means we have two junctions, right? JE and we have junction JE and we also have the junction JC. JE is in forward bias, JC will be in reverse bias. How many junctions we have? JE and JC. To operate the transistor in active mode, JE should be forward bias, JC should be reverse bias. Okay, and what is VEB? VEB is this emitter base voltage should be in forward bias and collector base junction should be in reverse bias. Forward bias means VEB should be forward bias means this positive of the terminal battery should be connected to P region. Since we are considering this P, N and P transistor, this P region should be connected to positive and this N region should be connected to negative. Then this VEB is in forward bias. Forward voltage across, this is VEB is nothing but the forward voltage across JE, forward voltage across JE, and that is what JE is nothing but emitter junction. In the same way, what is VCB or VBC? Is nothing but the reverse voltage across JC. What is JC? JC is the collector junction. Okay. Now, consider a PNP transistor here. A PNP transistor. If I consider a PNP transistor operates in active mode. If we have the emitter voltage is greater than the base voltage than the collector voltage. For what type of transistor? For PNP transistor. Then if we satisfy this condition, then transistor will be operates in active mode. Active mode means JE and JC. This JE should be in forward bias, JC should be in reverse bias. Okay. For example, if instead of considering this PNP transistor, if I consider this with the NPN transistor operates in active mode means what should be the condition? Just make it reverse. Make the reverse assumptions. VE should be less than VB should be less than VC. So this is what the NPN transistor satisfying condition to operate the transistor in active mode. Okay. Now, when transistor emitter junction is in forward bias, what is the first region we have? P, no? P region holes travel from emitter to base. P region holes travel from emitter to base, resulting in the current of IPE. What do you mean by IPE? Hole current through emitter junction, and electrons travel from electrons travel from base to emitter. Electrons will be travel from base to emitter. Okay. So that resulting current is what? INE. IN is nothing but electron current through emitter junction. Electron current through emitter junction. Let me define these values. Let me define these notations. What do you mean by IPE is? IPE is whole current through emitter junction, and INE is electron current through emitter junction. I hope that point is clear. Now what is the total current? Total current is IE. Total current is nothing but now what is the total current? IE is equal to total emitter current is equal to the summation of whole current through emitter junction and collector electron current through emitter junction, that is IPE plus INE. So this is what the total current through emitter junction, that is nothing but the net current through emitter junction. Net current through emitter junction. Okay. Now let me take another point here. As emitter is heavily doped, as emitter junction is heavily doped, the carrier injection, the carrier's injection from emitter to base, is much stronger. That implies IPE should be far more greater than IPE. That is, whole current through emitter junction is much more stronger than the electron current through emitter junction. So we can neglect this INE. I hope that point is clear to everyone. So the net current IE is approximated to only the dominant current, that is whole current through emitter junction. Okay. If you observe these points, what is the first point I have said here? As emitter is heavily doped, the carrier injection is from emitter to base is much stronger than base to emitter is very light. So we have neglected this value. As emitter to base, what current is flowing here? Whole current. You take this point here. Holes in P region is traveling from emitter to base. Whereas here, in electrons is the minority charge carriers in P regions will travel from base to emitter. So the total current through emitter junction is the summation of electron current, whole current through emitter junction and electron current through emitter junction. Since this part is very light compared to this is much more stronger, so we are taking only the whole current through emitter junction. So therefore the net current emitter current is only the whole current through emitter junction. Hope that point is clear. If you want, you can see in the diagram also. You see, this is for IPE. Whole current through emitter junction, whereas this one, electrons are moving from base to emitter. This is very less. So we are neglecting this. Okay. I hope that point is clear. So let us find this emitter junction. emitter injection efficiency. We also find this emitter injection efficiency. Emitter injection efficiency. Okay. This is defined by, this is denoted by what? Gamma. What do you mean by this emitter injection efficiency? It is the ratio of the current, it is the ratio of the current through emitter junction. It is the ratio current through emitter junction due to the carriers of emitter and the total current through the emitter junction. That is, it is the ratio of, gamma is the ratio of IPE to total current. You can even write here, it is the ratio of, current through emitter junction, is the ratio of current through emitter junction, current through the emitter junction due to the carriers of emitter, due to carriers of emitter and the total current through the total current through emitter junction, total current through emitter junction. So that is denoted by what? Gamma is equal to IPE divided by IE. IPE is nothing but whole current through the emitter junction and IE is nothing but the total emitter current. You can even replace this IPE is equal to, sorry, IE is nothing but the IPE plus INE. IPE plus INE for PNP type of BJT. For PNP type of BJT. Hope this point is clear to everyone. Okay. As emitter is heavily doped, as emitter is heavily doped, as emitter is heavily doped, as emitter is heavily doped and base is lightly doped, base is lightly doped, gamma is slightly smaller than 1, then gamma should be what? Lightly smaller than the value of 1. Okay. Okay. In a BJT, carrier flow from base to emitter is unwanted. As I already mentioned here, carrier flow from base to emitter, is unwanted, and hence base is lightly doped. Therefore, and hence base is lightly doped, and hence base is lightly doped. Okay. Now, when holes, let me also write here one more point. When holes enter base, when holes enter the base, a few of them recombine with electrons, and remaining holes will reach the collector junction and remaining holes will reach collector junction. Holes will reach the collector junction. Holes will reach collector junction. Okay, holes will reach the collector junction in the form of the current IPC, in the form of current IPC. So this is nothing but the whole current through the collector junction. Whole current through the collector junction. These holes get attracted by the negative voltage of the collector. These holes get attracted by the negative voltage. Get attracted by the negative voltage of the collector, and hence holes enter the collector region, Okay, so reverse voltage VCB does not, or reverse voltage VCB or VBC does not oppose the whole movement from N type of base to P type of collector. Reverse voltage VCB or VBC does not oppose the whole movement from N type of base to P type of collector. Therefore IPC, this IPC is nothing but the whole current through collector junction. Whole current through the collector junction. I hope that point is clear. Next point is the transport factor. Next point will be the transport factor is always defined by beta star or alpha t. What do you mean by gamma? Gamma is nothing but the emitter injection efficiency. And beta star and alpha t will be the transport factor. So it is defined as, it is a measure of the efficient transportation of carriers through base. It is a measure of efficient transportation of carriers through base. Efficient transportation of carriers through base. Okay, so mathematically how we represent this one? Transport factor is the ratio of IPC to IPE. Alpha T is nothing but the IPC to IPE. I hope this point is clear to everyone. Okay. This will be the first part. Next part we'll see in the next class. Okay.